So our next presenter will be Brad Douglas from the American Wood Council. Brad is Vice President of Engineering for the American Wood Council, which is the voice of North American wood products manufacturing, representing over 75% of the industry that employs over 400,000 men and women in the United States. With more than 33 years of experience in the wood product industry, he directs a program aimed at developing state-of-the-art engineering data, technology and standard on structural wood products, systems, and assemblies for use by design professionals and building officials that assure safe and efficient wood-based designs. He served on several standard development committees of organizations including ASTM, American Society of Civil Engineers, the U.S. Federal Emergency Management Agency Building Seismic Safety Council, and the International Code Council, addressing proper design of wood buildings for exposure to fire and structural loading, including wind and seismic loads. Mr. Douglas was the 2015 recipient of the Award of Merit and title of Fellow from ASTM International Committee D07 on Wood, which is the highest organizational recognition for individual contribution to standards activity. So let's welcome Brad for his speech. Thank you.
Thank you, Christian. So, Christian asked me to come and speak to you today about a study that we have been conducting. It's actually the second study of two full compartment test series that have been done in the United States. The study is in support of the tall wood activities in the United States. Specifically, I think Jennifer addressed some of it this morning, the International Code Council's Tall Wood Ad Hoc Committee, which is a group of regulators, fire officials, material interests, engineers, architects, and designers who have come together to try to develop prescriptive code changes that will allow wood frame construction up to 20 stories. And when I say wood frame, we're talking about heavy construction, what we have picked up or coined the term mass timber construction. So we're really talking about construction 7 stories and up. The topic today is, as I said, it's the second series of compartment tests. They are based on a real fire scenario. We basically took the contents, supplied the contents in an apartment size building, and met the requirements for a real fire scenario that has been identified in some of the standardization efforts in Europe and the United States. The purpose of this test is a little different than the earlier series. The purpose of this test is really to evaluate the occupant and the firefighter tenability of the compartment during a real fire. Whether they, can they get out of the building? What is the timing? Does the fire grow and spread beyond the room and then the compartment of initial exposure? So a quick description. This is a 2-story structure that was tested. It's basically, see if I can work this. It's basically identical top and bottom. This is the rough floor plan. It's a 30 by 30 foot, 9 by 9 meter space. It's separated with a load-bearing beam on both floors, CLT in the exterior perimeter, CLT floors and roof, then a non-rated partition in the middle. The CLT was a 5-ply CLT, Douglas fir, made of Douglas fir, 35 millimeters, 175 millimeter total thickness. Used a polyurethane adhesive, which is common in North America. And there was also a corridor constructed with a CLT around the compartment, and there were measurements taken to determine what, if any, fire spread occurred in this corridor and then down. This is a stairwell here. I think I've got a little better picture of that in a minute. There were several things that we noted in the early series of tests that we wanted to address in this series. One of them was the importance of sealing joints. We had quite a few problems in the original compartment test with not having the joint sealed. And so the contractors that put the building together did a very good job putting down joint sealing and intermescent caulk that allowed it to seal up, and we were able to use this facility for multiple tests. So once the rough structure was built, we then finished it like a one-bedroom apartment. So in the layout here, you can see this was a living room, a kitchenette that basically was open with kitchen cabinets. This was a bedroom, closet space, and then the bathroom and living closet. The corridor here, the stairwell. This is another layout with the dimensions. The one thing I'll point out, this was a 20-minute door by code. Had to be rated for 20 minutes. This was a 1.5 hour rated door, 90-minute door, also required by code. So this is kind of the steps through the finishing and supplying the furniture. In the kitchen area and also in the bathroom, which I'll show in a minute, we ended up putting a bulkhead and a drop ceiling in here. That would be where the electrical, heating, ventilation, air conditioning would be located. This is the vents for the HVAC system, the cabinets for the kitchen. This is one of the tests where we had 30% of the ceiling exposed in both the living room and bedroom, and we'll talk about that in a minute. We also had to supply furnishings, and that was more difficult than we thought it would be initially. We were trying to get to 550 megajoules per square meter. We filled the rooms with furniture. We brought in cabinets and filled those with old books. Still wasn't enough, so we ended up having to put several wood cribs around, as you can see in the pictures here, to get up to, it was about 565 megajoules per meter squared, I think, when it finished. The last test, test 5, was really an evaluation of what happens if the NFPA 13 sprinkler system doesn't engage. Very, very, very rare scenario that the sprinkler doesn't engage, but it has occurred where we've had an earthquake or some event has resulted in the loss of water. So this represents what would happen if the fire service were to arrive 20 minutes after being notified and either activate the sprinkler system or hook up their tanker truck and engage the water system. So the ignition source was pretty simple. It was cribs in one of the kitchen cabinets with accelerant here in the corner. And we had one of these brave researchers went in and lit it multiple times. It was not, when we first heard that was the way they wanted to do it, we were surprised, but it ended up not being near the event that we thought when they first ignited it. So the first test was, again, the benchmark test occurred on the first floor. And I've got a video here, if I can get Christian to start it for me. There's a lot going on in this video, but they're basically all of these cameras are linked, so it's all occurring at the same time from different camera locations. You'll notice down here in the bottom, they'll speed it up and slow it down so that we're not sitting here for the full 3 hours that this test was taken. But they've ignited the source back here in the kitchen. The kitchen becomes involved and it moves into the living room. I believe we're fairly close to flashover in the living room there. So we've had flashover in the living room. It's now spread into the bedroom. You can see the fire here coming through the doorway. This door was left over just to accelerate the time in which the fire spreads into the bedroom. Mattress ignited, so we have flashover in the bedroom. Both rooms are fully involved at this point. I believe they speed it up here soon. There we go. You can see this is the doorway into the quarter, the 20-minute door. This door did very well in the first two tests. I'll discuss it a little bit later, but it lasted, I believe, more than 30 minutes. It was rated for 20 minutes. By the time the door finally was consumed, the fire had declined to the point where it really didn't expose the quarter to much fire. For that reason, the 90-minute door to the stairwell never really saw significant temperature rise. The quarter door has passed. This test was terminated at 3 hours. We had intended to go to 4 hours, but we terminated it because as you'll see in a minute, the curve just didn't really do anything. For the sake of time, I have a video of all these tests. They're online if you're interested. Talk to me afterwards, and I can give you the links. But test 2 and 3 looked almost identical to test 1. Unless you had a stopwatch, you wouldn't be able to tell the difference because most of the fuel source is really the contents in the room. I do have a video of test 4, which is the sprinkler, if you want to switch to that. Found that one very enlightening to me. We talk about the advantages of sprinklers, but until you actually see a real fire scenario with a sprinkler, it really doesn't drive it home. So they've ignited the room. They've stepped out. I don't think they sped this up because it happens pretty quickly. Looks like it's double speed here. So the fire is growing about like what we saw in test 1. The smoke alarm has now triggered, and notification to the fire service would have occurred at this point. You see the flashing here in the room. Fire continues to grow. These sprinklers activate at about 140 degrees C, I believe. And they're activated there at 243, I believe it was. So all you see is steam now. And the fire's pretty much out at that point. So it never affected the bedroom, just started to fill the living room with smoke. I think we can stop that, Christian. So the results of the 5 tests on the surface are summarized in this table. As I said, the flashover in the first 3 tests, unless you had a stopwatch, you probably wouldn't notice there was much difference there. Test 2 and 3 occurred a little quicker. Flashover in the bedroom was almost identical. So the fire spreading to the bedroom in the first 3 tests. Flames in the hallway, the first 2 tests performed about the same. The 3rd test was, it failed very early at 13 minutes. The problem here was the door frame. They didn't have a 3rd door frame that fit exactly right, so they tried to modify the door frame to make it work. We didn't realize it until after the test, and we said, wow, this only lasted 13 minutes. Well, that's when the contractor admitted that he thought that using a different door frame would work, and it didn't. So that's an important lesson there. The compartment door, in this case, failed completely at 29 minutes instead of close to an hour. Again, we didn't have sprinkler activation in the first 3 tests. We did have it in the 2 minutes and 37 seconds is when it activated in test 4. And then in test 5, we activated it at 23 minutes, representing 20 minutes after the fire service would have been notified. And that test was pretty much the same result. It was extinguished. The fire had spread to the contents in both the living room and bedroom, but the sprinkler system was still able to control it. So there was over 400 streaming data measurements taken during these tests at the U.S. government's Alcohol, Tobacco, and Firearms Laboratory. I just pulled a few off to discuss. There were 20 thermocouple trees taking measurements in the room, 10 on each floor. We basically recorded the temperatures in both floors at the same time so that we could evaluate if there was any effects from one floor to the next. And this is pretty busy, but this is test 1, 2 locations in the living room. This is test 2, where we had the ceiling exposed, and this is test 3, where we had the wall exposed. Test 2, very similar to test 1, although the scale, I noticed this morning, the scale is off a little bit. This only went to 180 minutes. These tests, we terminated at 240 at 4 hours. So the scale is a little different, but you can see that they're both of these are cooled down below 100 degrees Celsius in the room. The wall test, again, we terminated at 240 degrees. The temperature was still elevated. It was above 200 degrees Celsius. But there was not significant charring in the CLT walls. This is the thermocouples, surface and embedded thermocouples. What the researchers did was they embedded thermocouples in this wheel pattern at various depths, some of them at the glue line, some of them approximately halfway to the glue line. And then if there was gypsum available at the surface of each of the glue lamb, of the gypsum layers. This is a little more interesting, although again, pretty busy. In the fully protected, the CLT is cooling down very quickly, below 100 degrees. In the floor, the exposed floor, we did see some of the thermocouples still increasing. It took about 30 minutes for it to increase about 15 degrees C. And so the test was to be terminated at 4 hours. The researcher said that, there's not any change between 180 and 190. It was marginal, minimal. But we did hold it to 4 hours, and it had pretty much stopped. The one thing was that we were getting right to the char temperature at the glue line. And that was at one location, so that's the one we're seeing right here. In the walls, it's a little more static here, but again, overall it was cooling down. So just closing, all of this testing, the 400 streams of data being analyzed, we've got the videos together. The Forest Products, U.S. Forest Products Lab was actually the researchers that worked with the people at the Alcohol, Tobacco, and Firearms laboratories to run the test in their full-scale area, and they will be publishing this in a general technical report sometime this fall, hopefully very soon, and it'll be at that website. So that's it.
Right on time.
Thank you.